Welcome to this presentation of an example of using Blackbird against a simple, commercially available frequency-agile radio transmitter. Using a spectrum analyzer display, we can see when a frequency-agile signal comes on the air by its pattern of transmission. In the current display, there are no frequency-agile transmissions. Signals are either on, off, or appear to be randomly turning on and then off. When a frequency-agile radio starts transmitting, here, it can be recognized by the appearance of short transmissions which follow each other. As soon as one signal turns off, it is replaced by another. This pattern of behavior can be seen even more clearly on a waterfall display like this spectrogram. The frequency-agile signal is easily recognized by the appearance of short vertical dashes that show the transmitter jumping from one frequency to another. It would be possible for you to manually note the frequency of each of the transmissions, how long each of the transmissions are, and what the bandwidth of each signal might be. However, the Blackbird will automatically do this for you. Here we have turned on the automatic detection capability of the Blackbird, and it is now detecting and cataloging each and every signal that it sees. We can go back in time and look at the characteristics of this frequency-agile transmitter, and we can then use these parameters to make the Blackbird automatically alert on characteristics that are included in this particular signal. For this example, first of all, we type in the start time that we noted that the frequency-agile signal was on the air, and then we type in the stop time that we noted the signal went off the air. Next, we enter a frequency a little lower than the lowest frequency that we noted that the signal covered, and then we typed in a frequency a little higher than we noted. In the center of the spectrogram, we can see the transmitting elements of the frequency-agile signal. We click-drag a box around these signal elements to select a set. We can see that there are a few signals that are being included in the set which we do not actually want to have included. Some of these signals are spurious noise from the transmitter when it switched frequency, and there are other transmissions that have nothing to do with the frequency-agile signal in which we are interested. To remove these spurious signals from our set, we simply right-click each of the signals that we do not want to have included and clear them from the set. Once we have a representative number of signals in our set, we can look at them for common characteristics. In this case, the signals belonging to the frequency-agile transmitter appear to have an on-time of around 488 milliseconds with a variable bandwidth of around 15 to up to 35 kHz. We now take these parameters and create an action in the Automations tab of the Blackbird interface. The first automation will only look at signals between the frequency limits of from 904 to 925 MHz, and will filter to see only signals that are from 300 to 500 milliseconds long. We also have set the filter in this automation to see only signals that have a bandwidth of between 15 to 50 kHz. Any signals that meet these criteria will then be tagged with Tag 1. The second automation looks for any signals that have been tagged with Tag 1 and performs a modulation recognition on this signal. The third automation then looks for any signal that has been classified by the modulation recognition as analog FM and then records that intercept. So, in summary, the system is now staring at the frequency band 900 to 940 MHz, and we have three automations running. One that identifies signals that are between 904 to 925 MHz, which are between 300 to 500 milliseconds long and have a bandwidth of between 15 to 50 kHz. The second that performs modulation recognition of each signal tagged with Tag 1, and the third which records each emission that is classified as analog FM. When the frequency-agile transmitter is turned on, Blackbird immediately recognizes the characteristics of the signal and starts tagging each matching emission with Tag 1. Modulation recognition is then run on each of the transmissions that are tagged, and then any signal that is recognized as being analog FM is then automatically recorded. In this particular example, the system continued to run for a few minutes before we returned to it, so we had to expand the time window, in this case back 5 minutes, in order to see the frequency-agile transmission. We then used the mouse to zoom into the period of time that our signal of interest was transmitting, adjusting for both how far back in time we wanted to view, as well as the time period we wanted to see. Next, we zoomed in on the frequency axis by typing in a lower frequency of 905 MHz and an upper frequency of 925 MHz. Finally, we fine-adjusted the time window, again using the mouse. We then opened the Snapshot Audio IQ Player application to replay the recorded signals, and we played each of the intercepted signals in turn. We then saved the intercepted IQ files in WAV format and imported them into a simple audio editing application.
1, 2, 3, 4.
And then we deleted the noise between each intercept. Resulting in a final product.
1, 2, 3, 4, 5, 6, 7, 8, 9,